Hi folks, welcome back to 9.4 Mathematical Induction. And so in this video, we're going to take a look at one last example on mathematical induction. And specifically, we're going to use induction to prove that the sum from k equals 0 to n of 2 to the k equals 2 to the n plus 1 minus 1. Okay? Now I know this is in a little bit of a different format than what we've seen in the other few examples, so let's write out what this actually is asking us to do. So what they're saying is if you have a series, and we start plugging in numbers for k, so we start with 0 and we add it to 2 to the 1 plus 2 to the 2 plus 2 to the 3 plus, and we keep going all the way until we finish at 2 to the n. But that should equal 2 to the n plus 1 minus 2 to the n plus 1 minus 1. Okay? So that's a rough translation of what this means. Okay, so let's start with our basis step. We're going to show that this is true for... Where do we start? Okay, we don't always start with 1. We have to start with whatever it tells us to start with. So we want to show that this is true for p sub 0. Okay, so p sub 0 is going to be 2 to the 0 equals 2 to the 0 plus 1 minus 1. So 2 to the 0 is 1, and this will give me 2 to the 1 minus 1, or 1 equals 1, which is good. So we've shown that this is true for the basis step. Now our goal is to do the inductive step, okay? So that means that we're going to assume this is true for 2 to the k. All right, everything added up until 2 to the k should equal 2 to the k plus 1 minus 1. And now we're going to use that to prove what happens if we have, instead of k, we have k plus 1. So again, everywhere I see a k, I'm going to include a k plus 1. So we want to prove that if I start from the beginning, and I add up all those, and then on top of that, I add k plus 1. That should equal 2 to the k plus 1 minus 1. Okay? Now, again, this step looks like a really long one, but if we notice that all of this is equal to 2 to the k plus 1 minus 1, we can replace all of this with 2 to the k plus 1 minus 1. So let's see what that gets us. 2 to the k plus 1 minus 1 plus 2 to the k plus 1 equals 2 to the k plus 2 minus 1. Okay. So what we're going to do here, strategy is a little bit different, okay? So in the past, with example 1 and 2, we did a lot of factoring, but in this case, factoring is not necessarily helpful. So what we're going to do is we're going to try and group our like terms. So 2 to the k plus 1, I have one of those, and then I have a second one. So that gives me 2 times 2 to the k plus 1, because I have 2 of those, and then don't forget about that minus 1. And that is, we hope, equal to 2 to the k plus 2 minus 1. All right, so now we're going to use our rules of exponents, all right? So rules of exponents say that if I have a number and I don't see an exponent written, it's really a 1. And rules of exponents say that if I have the same base and I'm multiplying, then what I do to the exponents is I add them. So that means that I can take this 1 and this k plus 1 and add them because they both have a base of 2. So 2 to the k plus 1 minus 1 equals 2 to the k plus 2 minus 1. And 2 to the k plus 2 minus 1 equals 2 to the k plus 2 minus 1. All right, so we have shown by induction that the sum of 2 to the the sum of the powers of 2 equal 2 to the n plus 1 and then minus 1. Okay? So there's a lot of different types of questions that you can prove using induction. I've chosen a few that seem relevant for pre-calc, but again, when you get into discrete math or linear math, you'll have a chance to try a whole bunch more and see really how they're used. Okay? Thanks so much.